So I'm going to try to help you figure out these problems about geometric sequences and series. And the difference between a geometric series, a geometric sequence and an arithmetic sequence is with an arithmetic sequence, when we subtract the two terms, we get the same number. So I'm like, for example, this example number 1, if I do 6 minus 3, I get 3. But if I do 12 minus 6, which is the next two terms, I'm talking about this one right here, that gives me 6. Notice how there isn't a common difference because it's changing. However, if we divide the second term by the first term, I get 2. If you divide the third term by the second term, you get 2. So here there's a common ratio, and this is how you find out what it is. You just take consecutive terms and divide them, and if they're the same value, then it's a geometric sequence. It's probably a geometric sequence, and it's got a common ratio. So try this. Well, maybe I should talk to you about this fraction one, and then of course then you notice how this one alternates between positive and negative, and when you divide them you get -2. So that can happen also with the geometric sequences. The common ratio could be negative. If you look at number 3, when you're dividing those, if I take 1/2 divided by 1, well, that's just 1/2. If I take 1/4 divided by 1/2, remember we're going to take the reciprocal and multiply. So in that case, the 2 and the 4 cancel out. So that gives you a common ratio of 1/2. So the common ratio is 1/2 for that in this case. Now you have the answers to these. Try this. Hopefully you can get that figured out. If not, give a yell. So I decided, if you've tried these, I'll actually show you how to do these. So for number A, they're telling us there's a geometric sequence. So if I do 5 divided by 1 or 25 divided by 5, in each case I get 5 as the common ratio. For part B, I'm noticing the alternating signs. So -9 over 3 is -3. 27 divided by -9. Notice I'm using consecutive terms. That's also -3. So that common ratio is -3. Okay, for letter C, -12 divided by 48 works out to be -1/4. And 3 divided by -12 is also -1/4. So in this situation, the common ratio is -1/4. And for the last one, it's also decreasing, so I know it's going to be a fraction less than 1. 18 divided by 54, I believe, is 1/3. And 6 over 18 is also 1/3. So this common ratio is 1/3, or 1/3. Okay, so they're giving us this general formula to get any term. That's the explicit formula for a geometric sequence. If you want to do a recursive formula, we'd write a sub 1. So let's suppose I look at this example number 4. I'm going to do the recursive formula, meaning I know what my first term is, and then what do I have to do to get my next term? Well, I'm going to take the term before it and multiply that by the common ratio. In this case, the common ratio is -32 divided by 64, which is -1/2. So that's my recursive formula. If I want to do an explicit formula, I can use that formula that they had at the top of the page here, explicit. So a sub n equals my first term, which is 64, times my common ratio raised to the n minus 1. And that will let me find any term in this sequence. If I wanted to find the 11th term, well, you can look at the example they did here. Maybe I ought to walk you through it. So to find the 11th term in the sequence, we're going to take the first term times -1/2 raised to the 10th power, because it's n minus 1. I'm looking for the 11th term, so 11 minus 1 is 10. So then we get to just figure out what 1/2 to the 10th power. They did it this way. I mean, there's also you could do this. They knew that 2 to the 6th is 64, and then they canceled out or they subtracted the exponents to get the -4. Okay, so, and certainly a calculator is okay to use this for. Use for this. So, question E, to try this, you've got the answer in the back of the handout. If you want to stop the video and go take a look at this, then come back and watch me do it if you need to. Okay, so first off, I want to find the common ratio. So -15 divided by 3 is -5, and 75 divided by -15 is also -5. So it looks like the common ratio is -5. So 3 times -5 raised to, let's see, the formula is n-1, so they want us to find the 6th term, so I'm going to raise that to the 5th power. I know my answer is going to be negative because I'm raising an odd number to a odd power, a negative number to an odd power, so that tells me it's negative. So I got my calculator and I use that to calculate it because I have no idea what 5 to the 5th is. And what I want, one thing I thought was a good chance to point this out to you. Really, we should be taking that negative numbers, enclosing it in parentheses, and raising it to the 5th power. That makes sure that the negative gets raised to the power that we are desiring. If you were to just type this in this situation, you get the same answer, and that doesn't look like a big deal. But what's really happening is that's taking 3 times -1 times 5 to the 5th. If you're raising that negative number to an odd power, well, that doesn't matter. But if you were raising it to an even power, it wouldn't take care of the negative. So you really your best bet is to make sure to enclose your negative number or your base, your common ratio in parentheses. That way, make sure you do the order of operations right. Be ashamed to do all that work and get wrong because your calculator entry error. Okay, so how do we find this? Now we're into series. How do we find the sum of a geometric series? Well, they give us this little handy-dandy formula. Unlike for an arithmetic series where you take how many terms divided by 2 times the first term plus the last term, well, this isn't quite so slick. It doesn't work out the same because the slopes are different. I mean, the increases changes, so you couldn't use some kind of linear model for this. But we could use some kind of exponential model, and this is a variation of those. Should I talk you through this first one? I guess so. So our first term is the 3. We know the common ratio is 2 because as it shows you here, 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is also 2. So we're going to replace all these values in this formula. Notice what they did. And then you're going to think about the order of operations. They got the -63 because 2 to the 6th power is 64. 1 minus 64 is negative 63, and then of course 1 minus 2 is -1, and then they just did the arithmetic to get that answer. So why don't you try to set these up? Stop the video, try to set these up, and then come back and watch what I'm going to do with them. Okay, so for 8, I see that the first term is 3, so a sub 1 equals 3, just like the other one. My common ratio is going to be 15 divided by 3, which is 5, and if I check to see 75 divided by 15 is also 5, so that is the common ratio. And I want to find the sum of the first 6 terms, so n equals 6. So now I'm just going to apply it to this formula, so find the sum of the first 6 terms. We take the first term times 1 minus the common ratio to the 6th power all over 1 minus the common ratio of 5. So that's going to give me 3 times, and let's see, if I grab my calculator, 5 to the 6th power works out to be 15,625. It's over negative 4, and 1 minus 15,625 is 3 times negative 15,624. I know that divides by 4. I see the negatives cancel out. I really don't want to do all that work. So I'm just going to multiply by 3, divide by 4, and I'm getting 11,718 is the sum of the first 6 terms in the sequence. All right. So for I, we see the first term is 2. It looks to me like I've got a common ratio of negative 1/2, but let's double check this. So negative 1 over 2 is negative 1/2. Is 1/2 divided by negative 1 also negative 1/2? It is. So then let's do the setup here. So the first term is 2 times 1 minus negative 1/2 here, raised to the 10th power, all over 1 minus negative 1/2. And let's see, what do we got? Well, 1/2 to the 10th. What is 2 to the 10th? Oh, 1024. So here, let me clean this up a little bit. So I'm going to get 2 times 1 minus 1 over 1024. All over, then you got to pay attention to the minus and minus, so that gives me 3/2. So just because we can, I'm going to do a little bit of arithmetic work. Let's see, I'm going to get common denominators here of, this becomes 1024 over 1024. 1024 minus 1 over 1024 works out to be 1023 over 1024 times 2 over 3. So at this point, I don't know, it's probably almost better just to grab a calculator. So order of operations, again, are very important with these things. So what I did is I did 1023 times 4, because 2 times 2 is 4, and then I did 1024 times 3, and got that, and then I divided those two answers, and then of course I looked at the answers on the packet that I provided you, and they gave me a fractional answer. So then on my calculator I just did that answer, and then if you press the math button, and then you'll see math frac, just press enter. If it's able to convert it to a fraction, it will. If this is a rational decimal, then it will. A rational fraction, it will. Okay? So then we've got this sigma notation. Remember, sigma means you're going to find the sum, so this is a series, and they tell us that, of course. Okay, so how do you do a problem like this? Well, as they suggest, find a few terms, and that'll let you get the first term, your common ratio, and of course they're telling us you look at that top number, and that's how many terms you want to find. Well, you got to be careful here, because you want to look at, I mean, your starting point, because I could do this. I could say, hey, find the sum of these 3 terms, and then, in other words, I'd have to find the sum of the 12th term, the 13th term, the 14th term, the 15th term. It might just be easy to generate them and add them up by hand, but you have to pay attention to what you're dealing with. So in this case, your first term would be the 12th term. Okay, so I can't just automatically say I need 5 terms. This would only be 3 or 4. Okay, so what else do you need to see here? This is the same formula, so once you've generated your terms and find your different values, you've got it. So take a look at it. See if you can't generate this one. This is 3 to the n. So once you try it, stop the video, try them, and then come on back and watch. Okay, so for this number here, what is it, letter J, I'm going to generate a few terms. So if n equals 1, 3 to the first is the first term, and then n is 2, right, because it goes from 1 to 5, so n is 2, so 3 to the second is 9, I'm sorry. And then the next one would be times 3 again, or 3 to the third would be 27. You know, maybe with this question, because it is so few terms, it'd be just as easy to generate them and add them up. However, you're not getting the sense of how to apply that formula. So let's do this. I see that my common ratio is 3. Of course, I probably could have seen that in the formula. R is 3, A sub 1 is 3, and I want 5 terms, and is 5. So using that partial sum formula, if I'm looking for S sub 5, the sum of the first 5 terms, the first term is 3 times 1 minus the common ratio to the 5th power, all over 1 minus the common ratio. So we're just going to grab it. Let's see, so it's going to be 3 times, let's see, 3 to the 5th is 243, I believe, and 1 minus 243, see, I think that's 243, and 1 minus 243 will be negative 242, and that's divided by negative 2, so it should work out to be 3 times 121. Let's check it out and see. And I believe it is. That's what I got on my calculator, and when the answer in the packet on the back says 636, so we're correct. So why don't you try K now if you haven't yet. So I'm thinking the common ratio is going to be 2/3, but if I didn't recognize that, let's generate a couple of terms. So n equals 1, 1 minus 1 is 0, 2/3 to the 0 is 1. The next term here, I better do I'm going to do this as a plus sign since it is a series. And then if n equals 2, 2 minus 1 is 1, 2/3 to the first power is 2/3. And then the next number would be 2/3 to the second power, so that would be 4 over 9, and so on and so forth. Yeah, so the common ratio is 2/3. The first term is 1, and I'm looking for the sum of the first 4 terms. So to use the formula, 1 times 1 minus 2/3 to the 4th power, all over 1 minus 2/3. Well, let's see. That first one, that leading one right here, I'm going to kind of ignore it. I'm just going to deal with what's inside. So 1 minus 16 over 81. So that becomes 81 over 81 minus 16 over 81. And 81 minus 16 is 65. So 65 over 81. And then on the denominator, that's going to 1 minus 2/3 is positive 1/3. So 65 over 81, 65 over 81 divided by 1 over 3 means I'm going to multiply that by 3 over 1. The 3 cancels in the 81 27 times, so the final answer will be 65 over 27. And if you'd done them with a calculator, you'd get some awful decimal value, but that's how you do that. So infinite geometric series. So what can happen is these series can go on, geometric series can go on forever and ever and ever. See, if you have an arithmetic series, you're always either adding a number or subtracting a number, so it'll never end. It'll always keep going, either to positive infinity or negative infinity, unless you add in 0 each time, and then in which case the common difference is 0. That's really not, it's kind of a trivial thing, the mathematicians call it. But with the geometric series, you can either, the sequence can either be increasing all the time, as in this case. In that case, the common ratio would be 2, right? And then in this case, so a half of a half is a fourth, half of a fourth is an eighth, half of a 16th is 1 over 32, half of 1 over 32 is 1 over 64. So in this case, we're adding on a smaller and smaller and smaller number each time. So this is going to settle down to a number. It's going to eventually, we're going to reach some limiting factor. If you're going to do calculus, you're going to see limits right off the bat. So we're going to. So the way you can tell whether or not a geometric series converges to a value is to take a look at the common ratio, and if the common ratio is less than 1, or between 0 and 1, actually between -1 and +1, it'll get small. It'll converge to a value. So just so you know, remember, you can find the common ratio by taking the second term dividing by the first term, and that's going to be 1/4 times 1 divided by 1/2, which is the same as multiplying by 2. I almost made that mistake, which is 1/2. So if my common ratio is less than 1, between 0 and 1, it'll converge to a number. Versus diverge, if it diverges, like this one diverges, it goes off to infinity and negative infinity. I don't know if you made that connection to Divergent Series. Get it? Divergent Series, and that's the name of that popular reading book. So you can look at these examples here. I mean, common ratio is between -1 and +1, so that is certainly going to converge to a number. And this one has a common ratio of 5, so that's divergent. That's never going to settle down to a number, won't converge. And this one, interesting, right, because what happens with this one, it keeps bouncing back and forth between a negative number or a positive number. So let's see what's happening here with these. So does this have a sum? Well, stop this video, watch those, and see if it's going to have if it converges, or what's the common ratio, and ask yourself if it converges. Then come on back. Once you think you've got them, come on back and watch my explanation if you want. So for this one, 16 divided by 4 is 4. 64 divided by 16 is 4. So this is a common ratio that's bigger than 1. So that's going to diverge. That's not going to have a sum. This one, -6, -30 divided by 5, that will be -6. 180 divided by -30, that's -6. So because that common ratio, the absolute value of that common ratio is bigger than 1, so that will not have a sum either. This one, let's see. So 1/3 divided by 1, or 1/9 divided by 1/3. In each case, you're going to get a common ratio of 1/3. That does have a common ratio that's less than 1, or the absolute value of that is less than 1. So that means this sequence, or this series, will have a sum. It'll settle down to be a number. Kind of interesting what those numbers work out to be, and that's where we're going to go next with this finding sums. So as you can see, the formula, it says you take the first term, take their common ratio, subtract them from 1, and you divide them. It's kind of a cool idea that works that way. So let's see, for this one, what's the common ratio going to be? 5 over 2, so how did they get that 1/2? 5 over 2 divided by 5 over 1 becomes 5 over 2 times 1 over 5. 5's cancel out, 1 over 2. And as you can see, you take your first term, put that over 1 minus your common ratio. 5 over 1/2 is going to be the same thing as 5 over 1 times 2 over 1, which is 10. So why don't you try these? Try finding the sum for these, if they exist, if it works. So the common ratio for D is going to be 1/3 divided by 1, which is 1/3, so it will converge. My first term is 1. Then I'm going to do 1 minus my common ratio. So 1 over 2/3, well, the reciprocal of 2/3, or 1 divided by 2/3 is the same as 1 times 3 over 2. That means this set of numbers, if you add it up till infinity, will be equal to 1.5 or 3/2. So how about this next one? So -1 over 4 is a common ratio of -1/4, as 1/4 over -1. Also -1/4 it is, so that will converge. So my first term is 4. My common ratio is -1/4. So minus the common ratio of the denominator. That becomes 4 over 5 over 4. Remember what I'm doing is this is the same as 4 over 4. 4 over 4 plus 1 over 4 is 5 over 4. So 4 over 1 times 4 over 5 works out to be 16 over 5 is what that series will converge to. So that's it for examples. Go ahead and try these paper-based problems. I encourage you to try these ones with variables. My Open Math will have those kind of questions on it. You do not have to do the geometric means questions again. Do this work, and we'll write you in a grade for it. Or you can just jump in and do the My Open Math stuff.